Today we're going to do section 7.5, trapezoids and kites. Properties of trapezoids and kites. A trapezoid is a quadrilateral with exactly one pair of parallel sides. The parallel sides are the bases. The base angles of a trapezoid are two consecutive angles whose common side is a base. A trapezoid has two pair of base angles. So as you can see, this is one pair of base angles, and then this is another pair of base angles. The non-parallel sides are the legs of the trapezoid. The height of the trapezoid is the altitude, as you see labeled, a perpendicular joining the bases. If the legs of a trapezoid are congruent, then the trapezoid is a parallelogram, as you see in the figure right to the right. Okay, so we're going to plot all of these points to form a quadrilateral. Then we're going to show that it is a trapezoid, and then decide whether it is isosceles. So first, to show whether it is a trapezoid, we need to, the two ones that appear to be parallel is AB and DC. So if it's a trapezoid, we're going to find the slope of AB, which is 3/9, which is 1/3. And then 2/6, which is also 1/3. So we know that they are parallel. So right now we know it's a trapezoid. To figure out if it's isosceles, we need to find the length of AD. We know they're not parallel, AD and BC. So because they're not parallel, we know it's for sure a trapezoid. Since quadrilateral ABCD has exactly one pair of parallel sides, it's a trapezoid. Now, it is isosceles because AD equals 5 and so does BC, as you can see using the Pythagorean theorem. So you can see that that's 5 as well as that by using the Pythagorean theorem. Isosceles trapezoid base angles are congruent. If a trapezoid is isosceles, then each pair of base angles are congruent. So in this picture, A and D are congruent, and also B and C are congruent. Then the isosceles trapezoid base angle converse says if a trapezoid has two pair of base angles that are congruent, then it is isosceles. So one is the trapezoid base angle theorem, the isosceles trapezoid base angle theorem, and one is the converse. Find the measure of the remaining angles. So you can see that it is isosceles. So we know that angle D are congruent, and that is 42. We also know that those are parallel, so they are supplementary angles. So you can find that as 138 as well as angle C is 138. Isosceles trapezoid Isosceles trapezoid diagonal theorem. A trapezoid is isosceles if and only if its diagonals are congruent. So those diagonals would need to be congruent. So given this quadrilateral, find the value of RT if QS is 3x plus 15 and RT is 5x plus 7. And we know that it's isosceles. So because it's isosceles, we know those diagonals are congruent. So we can set the two equations equal to each other and then just solve. And then we plug it back into the equation and we figure out what RT is. Next is the mid-segment of a trapezoid is the segment that connects the midpoints of its legs. Properties of the mid-segment of a trapezoid are similar to those of triangles. So if you look at them and you recall that DE is X and AC is 2X. So the mid-segment of a triangle is parallel to the base and half the length. Therefore, the trapezoid mid-segment theorem says if you add up both bases and take half of it, it equals the mid-segment. So you're going to take the average of the two bases. Notice that the trapezoid, the mid-segment, is parallel to both bases. So, given that information, how do you find WV? Well, there you would just add up the length of the two bases and divide by 2. Simple. And then for example 5, the missing base is DG, so we'll put a variable there. We'll add it up and divide by 2 and set it equal to what the mid-segment equals, which is 19. So we can multiply both sides of the equation by 2 and just subtract 13, and we've got our answer. Okay, given a trapezoid with these vertices, find the coordinates, the endpoints of the mid-segment, and the length of the mid-segment. So first thing you want to do is plot. Always we're going to plot. And then we want to find the midpoint of those legs. So we know the midpoint formula already, so we're just going to plug it in. And I'm going to find the midpoint of the other leg, which is SR. I'm going to use the midpoint formula that you already know and plug it in. And then I can connect them. Then it says, then find the length of the mid-segment. So we can find the length of the mid-segment by just using the distance formula. And you can simplify the radical there. Okay, properties of kites. Property of kite. A kite is a quadrilateral that has two pair of consecutive congruent sides, but opposite sides are not congruent. Kites have properties similar to those of special parallelograms. However, remember that the kite are not parallelograms. No parallel sides, so it's not a parallelogram. So the kite diagonal theorem says if a quadrilateral is a kite, then its diagonals are perpendicular. And the kite opposite angle theorem says the opposite, if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. and it's the pair that's connecting non-congruent sides. So we're going to prove this theorem. So we're given that it's a kite, and we know that those sides are congruent. We also know that BD lie on the perpendicular bisector of AC from a theorem we learned a while ago that says if a point is equal distance from the endpoints, it bisects. So if it's equal distance from the endpoints, it bisects AC. It lies on the perpendicular bisector. And so it is equal distance, so that means that BD lies on the perpendicular bisector. Since BD lies on the perpendicular bisector, then we know that BD is the perpendicular bisector, because if we connect those points, through any 2 points, there is a line. And then by the definition, we know it's perpendicular. Okay, so that was just proving the kite diagonal theorem. All right, determine if each statement about the kite LKMN is true or false. So this is a kite. So since it's a kite, is this true? Is KM perpendicular to LN? And the answer is yes, it is true. And so we can mark everything we know here. And once we have everything marked, we should be able to go down the list and see if so we know that they're perpendicular, we know that they bisect, so then we should be able to go down the list and state everything we know. So that one's true. So angle KJN is congruent to angle MJL. We also know that angle NKM is not going to be congruent to KMN. We also know, of course, KJ is not congruent to JM. But we do know that JN is congruent to JL. We also know that KN is congruent to LK. And we also know that angle KNM is congruent to angle KLM. So find the measure of angle C. So we know that they need to be congruent because they are the one pair of opposite angles that are congruent. So we're just going to add it all up and say it equals 360 because it's a quadrilateral. And then we're going to add 80 and 50 and subtract it over to the other side and divide by 2. And that's what the base angles are equal. And then we want to find X, and we know that GE is the perpendicular bisector of AF. So that means it bisects it. So since it bisects it, we know those are congruent, so we know those line segments equal each other. So we're going to add 1 to each side and multiply by 10. All right, so we're going to take a moment to fill out this chart here. So when you got a parallelogram, opposite sides parallel, yes. Opposite sides congruent, yes. Opposite angles, diagonals bisect each other, yes. So we'll get to the other couple, but let's just start with these. So the rectangles are opposite sides parallel, congruent, opposite angles, diagonals bisect each other, yes. Then on a rhombus, which means it's a parallelogram, but all the sides are the same. Yep, all that's true. Then on a square, which means it's a rectangle, but it has all sides congruent. That's true. Then you got a trapezoid, only one pair. And then when you look over here, the diagonals are perpendicular. That one is only a rhombus and a square and a kite. Then diagonals are congruent. That's only a rectangle, a square, and an isosceles trapezoid. And then right angles is only going to be four right angles is only going to be a rectangle. It's not a rhombus, so let's erase that because that is not a rhombus. And it's a square. And then four congruent sides, we know that's a rhombus and a square. Okay. Give the most specific name for each quadrilateral. So the most specific name there has to be a parallelogram. There's no other information there. This one has to be a trapezoid. And it's an isosceles trapezoid because you've got one pair of parallel sides and then the other ones are congruent. So it's a trapezoid and it's isosceles. The next one is a kite. The next one has to be a trapezoid, and it's not isosceles because those diagonals would be congruent if it was. And then the next one is just a quadrilateral. There's no other distinguishing features. And then in the last one, we should be able to find the missing angle, and since we do, we are able to say it's an isosceles trapezoid. Okay, so that's this section. So now you can start working on your homework and your classwork. And have a great weekend, and I'll see you all on Monday.